Hey all, this is Raj here, and friends, I'm so excited after watching the NVIDIA presentation by Jensen Huang. I'm going to talk about a small part of his presentation which might have not registered to ordinary lay people, but which matters a lot to people who have a background in computers. And you need to understand that because as a genomics investor and as an AI investor, this is going to be very, very important for future success in investment and in valuation. So that's what I'm going to do today. So let's get started.
People ask me, how did it start? What got you guys so excited? What was it that you saw that caused you to put it all in on this incredible idea? And it's this. Hang on a second. Guys, that was going to be such a moment. That's what happens when you don't rehearse. This, as you know, was First Contact, 2012, AlexNet. You put a cat into this computer, and it comes out and it says, cat. And we said, oh my God, this is going to change everything. You take 1 million numbers, across 3 channels, RGB. These numbers make no sense to anybody. You put it into this software, and it dimensionally reduces it. It reduces it from 1 million dimensions. It turns it into 3 letters, 1 vector, 1 number. And it's generalized. You could have the cat be different cats. And you could have it be the front of the cat and the back of the cat. And you look at this thing, you say, unbelievable. You mean any cats? Yeah, any cat. And it was able to recognize all these cats. And we realized how it did it. Systematically, structurally, it's scalable. How big can you make it? Well, how big do you want to make it? And so we imagined that this is a completely new way of writing software. And now, today, as you know, you type in the word CAT, and what comes out is a cat. It went the other way. Am I right? Unbelievable. How is it possible? That's right. How is it possible you took 3 letters and you generated 1 million pixels from it, and it made sense? Well, that's the miracle. And here we are, just literally 10 years later, where we recognize text, we recognize images, we recognize videos and sounds and images. Not only do we recognize them, we understand their meaning. We understand the meaning of the text. That's the reason why I can chat with you. It can summarize for you. It understands the text. It understood, not just recognizes the English, it understood the English. It doesn't just recognize the pixels, it understood the pixels. And you can even condition it between 2 modalities. You can have language condition image and generate all kinds of interesting things. Well, if you can understand these things, what else can you understand that you've did?
Welcome back, friends. That was Jensen Huang of NVIDIA talking excitedly about generative AI being able to recognize a cat and then being able to generate the image of a cat when given the command to draw a CAT cat. For those who are not from the computer technology field, we need to expand this so that you can realize what a great achievement this is. Imagine that you can feed pictures of thousands of dogs to a computer, and the computer intrinsically understands the concept of a dog. Then, if you show any dog, it should be able to recognize it. Well, what if you show just the rear half of a dog? Will it recognize it as a dog? Well, that depends on the training data. Can it project the image of a dog when commanded? Yes, again, it depends on the architecture of the generative AI. Let me explain. Once the generative AI goes through a whole range of images of a dog, then it understands the concept of a dog. How does it understand the concept of a dog? That's what I'm planning to explain to you. And I would say that generative AI refers to a class of artificial intelligence techniques used to generate new content that resembles or is similar to input data it has been trained on. Unlike traditional AI systems, they rely on explicit rules and instructions. Generative AI models learn patterns and structures from large data sets and can autonomously produce new content. For example, if you are given it thousands of images of a dog and then you ask it to produce the image of a dog, it will create a dog, all new dog on its own, which will be a dog that you can recognize as a dog. So basically the generative AI is on the same wavelengths as human in the terms of understanding the concept of a dog, recognizing it and drawing it. Generative AI models are trained on vast amounts of data. These data can include images, text, audio, or any other type of information the model is designed to generate. During training, the model learns the underlying patterns and features of the input data. This is typically done through techniques like deep learning, where neural networks are used to extract complex relationships from the data and store it into a database. Once trained, the generative AI model can generate new content by sampling from the learned patterns that it has saved. For example, a generative AI model trained on the images of faces could generate realistic looking portraits of people who do not actually exist. Generative AI can produce a wide variety of outputs, often exhibiting creativity and novelty. This ability to generate new content makes generative AI useful in various applications, including art generation, text generation, music composition, and more. Generated content is often evaluated based on criteria such as realism, coherence, and relevance to input data. Feedback from users or additional training data can be used to refine and improve the generative AI model over a period of time. Let's revisit the case of dogs. We can recognize a dog regardless of its breed and size. However, from a generative AI perspective, we need different considerations. If I train it on a picture of Maltese dogs, it may not recognize other dogs. This is the focus of training concept. If the training data includes labels like Maltese dog, and then I give it a whole range of Maltese dog pictures, then the model will learn to identify Maltese dogs. There is a risk of overfitting the model to training data. This means the model becomes too good at recognizing only Maltese dogs and performs poorly on anything different. Labels can help reduce overfitting, but it is still a concern with limited training data variety. Now, if you include pictures of German Shepherd dog with the label German Shepherd dog, then the generative AI has a better ability to identify dogs in general as opposed to only Maltese dogs. When we train the generative AI, it converts the images into numbers and tries to find patterns in them. These patterns will be used by the generative AI to recognize the dog, and that's how the whole magic works. Generative AI model types for image recognition and image generation are different. If the generative AI model is designed solely for image generation, it may not inherently possess the capability to recognize objects or parts of objects. Instead, it learns to generate images that resemble those in the training data set based on statistical patterns and features. Recognizing objects from partial information typically falls under the domain of object detection or image classification tasks, which are different from image generation. While some generative models may learn to capture local features or textures present in the training data, they may not generalize well to recognizing objects from partial views. However, techniques such as transfer learning could potentially enable a generative model trained on images of roses to perform object recognition tasks, including recognizing partial views of roses by fine-tuning the model on a data set that includes partial views or by incorporating additional training data. The model may learn to generalize and recognize objects more robustly. Transfer learning is done through a pre-trained model which is used as a starting point for this new tasks. So this pre-trained model is what Jensen Huang was calling as NIPS. So the pre-trained model has got all the foundational information about shapes, colors, texture, the foundation of the universe in which we live. And then that becomes the starting point for training it on new tasks. This model has learned valuable features and patterns about shapes, colors, and object composition even before it arrives to you. So the initial layer of knowledge is the building block or foundation on which we are going to build. This helps specific training in the new domain where it is to be deployed. Here, training on elements of the new domain will be overlaid on its existing fundamental knowledge, and hence learning is deeper, faster, and richer. The new layers are specifically aimed at the new domain where generative AI will deliver. Certain architectures such as convolutional neural networks, also called as CNNs, are commonly used for both generative tasks like image generation and discriminative tasks like object recognition. Architectures that have been trained for both tasks simultaneously or sequentially may exhibit better performance in recognizing objects from partial views. It is exciting to see how we are progressing faster with more powerful GPU and more powerful data centers or AI factories. This is absolutely amazing. There's a lot I am excited about, and I want to share all of that with you, but we have a limitation of time. I want to keep our videos short, 15 or 20 minutes at the most. So I'm going to end it here, but I believe that all of us need to understand AI to survive in the future. In the next videos, I'll be talking about robotics and AI in the Omniverse and how the three of them fit together and how they are used. It's absolutely amazing how they have conceptualized this entire training model for robotics. And I'm also going to talk about proteomics and genomics with AI. The BioNemo model, which I was talking about earlier in one of my earlier videos, maybe 6 months ago, I had spoken about BioNemo. So AI is now heavily involved in creating new proteins, understanding the existing universe of proteins and engineering proteins, and also in the study of genomics and new pattern matching in genomics to find new areas where gene editing can be done to tackle diseases where multiple genes are involved in triggering a particular disease. So all kind of complex things can be done using AI because of its tremendous capability. And friends, the most exciting thing is that whatever we have so far, based on which ChatGPT and other things are running, is just the tip of the iceberg. So we have 10 times more powerful platform that was unveiled yesterday by NVIDIA, and that has been pre-ordered by many companies who are going to upgrade their platform. And the way NVIDIA has designed this new high power GPU is that they just have to slide out the old GPU and plug in the new GPU. That's about it. So transfer from the older version of GPU to the new one is going to be very easy. And now this is going to spawn a lot of new economics. So far, people were dying to get the basic NVIDIA GPU. And now when big companies start upgrading to the latest, the old ones will be available. If the companies decide to keep it for other tasks, then there'll be extra AI computing available, or else those will be sold at a cheaper rate to other companies, which will now be able to enter the AI field and start working on it. So the AI power is going to be secularized, and it's happening very rapidly. And this is absolutely amazing, my friends. And I hope you share the excitement with me. And until then, I hope you stay safe and have a good time. Exciting times lie ahead for us, my friends. I'll catch up with you again in the next video. Bye for now.